Hello students, let's start the next part of our topic, that is nothing but deficiency of an element. When an essential element is at low concentration in the plant tissues, it will result in the decrease in the normal growth of plant, and which will affect the crop yield and produce more or less distinct deficiency symptoms. Okay, so what will be happen actually if we already saw some macro elements as well as some major nutrients, secondary nutrients required for the plant growth, isn't it? And when what will happen here when an essential elements, as we already know here, some essential elements required for the growth of plant. When essential elements is at low concentration, when an essential element is at low concentration in the plant tissues, what will happen? It will result in the decrease the normal growth of plant. It will result decrease in normal growth of plant. And if normal growth of plant get decreased over there, then what will happen? It will affect the crop yield as well as, and it can be produce more or less distinct deficiency symptoms. So let's see which are those particular symptoms can be produced over here because of what? Deficiency of an element. What I mean to tell you is that when essential elements are at low concentration, it means what? If they are in the less part, it will affect the growth of plant itself. So more or less it will affect the growth of plant. What will happen actually over there? We can discuss over here. So in that case, let's start here. Which are the symptoms we will going to deal here? In that first, typical deficiency symptoms are not clearly defined. The symptoms which can be observed over here, they are not clearly defined. Okay, so it can be the effect is due to the other nutrients also, and the secondary cause like disease symptoms may cause because of what, or we can also tell it as a secondary cause of deficiency of an element, or decrease in the growth of particular plant, or decrease in the crop yield because of why, like disease may happens to that particular plant, or it may be because of herbicides to we are using to remove the herbs from that particular crop plant or crop area. Okay, then toxicity, because of the toxicity, and again, or insect infections, or maybe because of the insect infections, and also again many more reasons are there, etc. We can tell it is as. Okay, so again next reason what, or next symptoms is what? Waterlogged conditions. Waterlogged conditions means there are some soil areas where water cannot be absorbed that particular soil or cannot be moved from that particular soil. Also water will remain as such in that particular soil. Such area we call it as a waterlogged conditions. Supply of water not happen properly in that area, we call it as in waterlogged conditions, or we can also call it as in dry soil. Okay, and mechanical damage can often create symptoms like mimic deficiencies. Okay, and again also mechanical damage. Mechanical damage also create some mimic deficiencies. Okay, then mimic deficiency means what? Here mimic deficiency means actual deficiency was different than that of what deficiency caused by the elements. That we call it as a mimic deficiencies. We used to call in the local language, isn't it, mimicry? The same way here also some mimic deficiency also can happen. And again deficiency symptoms always indicate the severe starvation. Starvation, insufficient crops, or if crops went off from that particular area, what will happen? They will not get for proper feeding, so starvation may happen. That we call it as starvation, not getting proper food for proper timing, we call it as starvation. Now the second part of this particular deficiency of an element, we can see insufficient levels. Okay, so second part, insufficient levels. Insufficient levels. So just to see what is the heading part for this insufficient levels. What is the meaning of insufficient level? When the level of essential plant nutrients, when the level of essential plant nutrients, when the level of essential plant nutrients is below the required amount for optimum yield. The required amount for optimum yield. What when the level of essential plant nutrients means how much level we want is below than that, how much we required, then that is it will happen imbalance in between that, isn't it? Or we can also tell it is as when there is imbalance, when there is imbalance with other nutrient, it is considered as insufficient. With other nutrients, it is considered as insufficient. Okay. The symptoms of these conditions are seldom clearly visible, resulting in the poor yield. So what we want to tell in this insufficient level means actual which nutrient we want, means if these nutrients are not present, then that particular plant will not grow properly, isn't it? If these nutrients are not present at all, or how much level we want, Okay, how much required minimum level we want, that much also if it is not present, it means what, if there is an imbalance with other nutrients, then that considered as a insufficient. And because of this, what will happen, what will the effect because of this, poor yield of that particular plant, or that particular plants will not grow properly, isn't it? And again, the seldom clearly visible, the whichever the symptoms which are available over, they can be clearly visible to all, isn't it? So this is about the insufficient levels. Now the next term that we see, that is nothing but toxicity. So let's start the next term, that is nothing but toxicity. Certain essential plant nutrients, if it is taken up in the excess, what I want to tell you is that whichever the things you are going to supply for the plant, that is in the limit manner, or how much we have to supply, that much only we have to supply. If it went in the excess form, more than it is required than that of form, then what will happen, it causes the nutrient imbalance. And what is the result for nutrient imbalance? If it is more nutrient went to that particular crop, poor plant yield. Okay, then again delayed maturity, poor plant yield, plant growth means what, plant will not grow properly at all, we call it as a poor plant growth. Then again, what is the next part we can going to deal for that, that is nothing but what, delayed maturity. So what is this particular delayed maturity? Delayed maturity means, consider if any crop comes in the 3 months. Okay. And if toxicity happened, essential elements more in we went excess gave, then that particular crop will come in the 5 months. It require 5 months or more than that of 3 months. That we call it as a delayed maturity. Again, stunned and spindly growth. Stunned means, consider if particular crop can be moved actually 3 feet of this particular height, then because of this excess or imbalance, what will happen, only 1 feet, only this much crop will come, 1 feet, or simply 2 feet it will not move to the 3 feet, that we call it as a stunned growth. Spindly growth, some crop will move like this, spining form, instead of grow properly. Okay, they can be moved like this. Okay, they are just spindly growth, isn't it, that we call it as a spindle growth, spindly growth. Okay, so such things happen because of what, toxicity itself. So let's we move next part of our topic, that in detail we will going to deal, that is nothing but macronutrients, and trace metal in the soil, very important part. Okay, trace metals in soil. So one by one I will going to tell you the elements. Let's me start this particular macronutrients and this particular trace elements, which are trace metals which are there in that. Nutrients, we already know that the nutrients already get classified in that. First, primary nutrients, that particular nutrients we used to call it what, yes, macronutrients. Okay, primary nutrients. Next, yes, secondary nutrients, and third type what, micro. These two are what, macro, and third type which will be there, micronutrients. Okay, then again this primary nutrient, I have already discussed this part, so I want to tell you that one by one these three nutrients, how it can become form taken by the plant, and the chemical symbol of this particular nutrients itself. Okay, so I will discuss first this primary nutrients itself. One by one we will going to deal. So let's see nutrients, chemical symbol, and from taken up by the plant. Okay, or form of plant can be absorbed by that particular nutrient. Now the first type which will be there, that is nothing what, which is our first type, yes, A, primary. primary, or may also call it as what? Yes, macronutrients. Macronutrients. It is very easy part. So one by one we will going to deal. In the macronutrient, first element which will become, that is nothing but what? Carbon. And you have to know the symbol for this particular carbon. Which is the symbol for carbon? Yes, C. And from where, or from taken up by the plant where? Yes, carbon can be absorbed from what? Carbon dioxide and also HCO3. These are the two forms from which plant can be absorbed. Next element which will be there, that is nothing but hydrogen. Yes, very important element required for the growth of plant, essential for the plant. Symbol hydrogen, and from where it can be took? Plant water, isn't it? Next, third very important element, carbon, hydrogen, and yes, oxygen, symbol O, and H2O itself, and again air, that is oxygen. Next, which one is that? Nitrogen. Okay, nitrogen, symbol for nitrogen N, and from where? Yes, NH4 plus as well as NO3 minus. Okay, next one, phosphorus. Okay, phosphorus, symbol for phosphorus, yes, P, and again H2PO4 as well as HPO4 2 minus, isn't it? Next again, potassium. Potassium, symbol for potassium is yes, K, and where it can be absorbed? K plus. Okay, so these are about what? Macronutrients, and these are of all primary itself. So next term which will be there, that is B, secondary nutrients. Secondary, these are also macro itself. Secondary nutrients, which are those? Let's we see one by one. In that first secondary nutrients, calcium first, calcium, symbol Ca, Ca2 plus. Next element, magnesium, magnesium, symbol for that Mg, and again Mg2 plus. Okay, so next one I will write here 6, here 7, here 8, and here 9. Sulfur, symbol yes, SO4 2 minus. So this is about what? All macronutrients. So not need to tell it is as in once again, carbon, CO2 and HCO3 from which this plant can be absorbed, hydrogen from water, oxygen from water as well as oxygen, nitrogen from ammonium cation as well as nitronium ion, phosphorus H2PO4, phosphoric acid is there, and dihydrogen phosphate also is there from which phosphorus can be absorbed, again potassium K plus. Again secondary nutrients which are there, calcium cation, calcium 2 plus ions, Mg2 plus ion, again SO4 2 minus ion, from which this secondary nutrient, these all 9 nutrients which are there, they are macronutrients. These are also very much essential for the growth of plant, and this primary, they are must and should be there, then and then only plant can be grow easily and softly. But secondary also we require for as a booster for the every plant body. Okay, so now let's we move the next part, as we already know there, micronutrients. Okay, see, now the third part I have already discussed, that is nothing but what? Micronutrients. It means what? Trace elements or trace metals, very less quantity it requires. So next one, number will be of 10. In that first is iron, symbol for that is Fe, and it is present or took by a plant by Fe plus 2, and again also Fe plus 3 and also chelate. Okay, next 11 I'll write zinc. Symbol for this Zn, took by plant Zn2 plus Zn hydroxide as well as chelates. I hope you already know this meaning of chelates. Then next one, manganese. Symbol for that Mn, under the form which required for the plant Mn2 plus and also chelates. Next, copper, Cu, required plant form Cu plus 2 as well as chelates. Next, boron. Okay, again symbol for that B, require boron hydroxide. Next, molybdenum. Molybdenum, symbol for that Mo, oxide, in the form of oxides it will require peroxides. Next, chlorine, Cl minus. In the last class we have already revised about this, isn't it, about the plant nutrients, in that major, secondary, micro, and also what is the meaning of other plant nutrients which are not required as such but required for their food, as well as toxic elements also we have already described, just like of selenium, lead, thallium, arsenic, fluorine. Because of that soil become toxic. And again some elements which are there, they are freely absorbed by the soil, which can be stimulate the growth. This just like of lithium, strontium, radium, mercury as well as silver, isn't it? We have already described about this. And today's class we saw about the deficiency of an element, what will happen because of deficiency, which are the symptoms for that. Next we saw the insufficient level. Next we saw about the toxicity. And after that again we have saw about the micronutrient as well as the trace metals in the soil. In this we saw about the which form the required plant for the absorption, it means so that can be reached towards the plant. Now let's start the next part of our topic, that is nothing but soil organic matter. SOM. As we already know here, soil is present in what? Nature itself. It means that it consists of, as it is soil organic matter which will be there, it consists of living organisms, dead plant and animal residue, So it consists of what? Living organisms. What it means? The leaves of the plant, it may be contains, or fruit, ripened fruit may sometimes fall on the soil itself. They can be decomposed. And again dead plant, sometimes plant also can be become dead itself. And again animals also become dead itself and they will decompose. That is dead plant and animal residues. Okay. And it is most chemically active portion of the soil. It is most active portion of the soil. Most active, chemically active, I will tell that, chemically active portion of the soil. And again next part, it is a reservoir for the various essential element. It is reservoir for various essential elements. So what I mean to tell you is that it is a reservoir. It can be reserves the all essential elements over there. Okay. It promotes the good soil structures. Next, it can be promotes good soil structure. It can be promotes good soil structure. Next, soil structure can be promoted by this particular soil organic matter. It means how much that particular soil is good in condition can be defined by the soil organic matter. Next, buffer soil pH. Buffer soil pH. Next, promotes good air and water relation in plant. Promotes good air and water relations in plants. Okay. So these are the some characters of the soil organic matter. So which are that soil organic matters characters? We will see one by one once again. Just to see that or just concentrate on it itself. We will see one by one over here. In that first, it consists of living organisms, dead plant and animal residues. So all the unwanted materials which can be fallen on the soil itself, it contains over there, and it is act as a good part for the soil. It is most chemically active portion of the soil, isn't it? And it is reservoir. It can be reserves the various essential element over there. It can be promotes the good soil structure. Next, buffer the soil pH means pH of the whether the soil is acidic in the nature or it may be in the basic in the nature, which can be promoted by this particular part, that is buffers the good soil pH over there, isn't it? Next, it promotes the good air and water relations in the plant, isn't it? Now let's we see the next part of our topic or itself, that are nothing but functions of organic matter in soil. So next part, functions of soil organic matter in the soil. So as we already know here, various essential elements which can be present over there. So which are the functions soil organic matter in the soil itself? So in that first function is what? It supplies nitrogen, phosphorus, sulfur and other secondary micronutrients for plant growth and other secondary micronutrients for plant growth. Okay, this is first. What I have told that it can be supply the nitrogen, phosphorus, sulfur and as well as other secondary micronutrients. So which are those other secondary micronutrients? So these are the secondary micronutrients. Iron is there, zinc is there, manganese is there, copper, boron, molybdenum and chlorine. It also can be provided by SOM itself. Next, holds up 20 times their weight of water. How much water holding capacity they are having means they can be hold up to 20 times of their weight of water. Okay. They can be holds up to 20 times of their weight of water. This is of second one. Again it can be holds cations and anions and release them slowly to the tip of root. So what? Again they can be holds cations, as we already know cations means what, and as well as anions, and release them what? Slowly. Cations carbon containing positive charge, anions carbon containing negative charge. Electron rich species, electron deficient species. These are also required for the mechanism for the plant growth. So they can be contained, it can be holds cations and anions and release them what? Slowly. Now the next, the ratio of carbon, nitrogen, phosphorus, the ratio of carbon is to nitrogen is to phosphorus is to sulfur is 10 is to 1 is to 0.5 is to 1. Sorry, 0.1. Okay, so what I want to tell you is that the ratio which will be there, which can be keep constant by this SOM, is carbon is C10, again nitrogen is of 1, phosphorus is of 0.5 and sulfur is of 0.1. Okay, this can be ratio keep constant by this particular soil organic matter. Next, effects the breakdown of pesticides and weedicides, which can be effects the breakdown of pesticides and weedicides. As we already know here, there are some unwanted part or unwanted material also present along with our crop in the soil itself. So which can be required some pesticides to remove the pest, and to remove the weeds also we required weedicides. So breakdown of these two material we need what? SOM itself. Now the next, chelates micronutrients, which are those such as zinc is there, manganese is there, copper is there, making them more available for the plant roots. Okay, next one is what? Chelates micromolecules such as what? Zinc, manganese, copper. This SOM make them more available for what? Plant roots. To the what? Plant roots. Okay. So the next one, buffer extreme acidity, salinity and alkalinity. So next function is what? It can be buffer what? Extreme acidity. If it is more acidic, it will make somewhat basic. Next it can be buffer what? Salinity. And again what? Alkalinity also it will be get buffered. Okay. So these are the some function of what? SOM itself. So let's start the next part of our topic, fate of organic material added to the soil. So what actual thing is that organic material which will be added to the soil, and because of that the soil which will be become more and more good in the nature. Okay, so how it can be added, what will be happen actually, we will see one by one over here. So in that first one which will be there, if organic material which will be there, it undergoes the decomposition, that is only biodegradable material through soil macro and micro, fauna and flora. Fauna and flora are nothing but, fauna is of animals and flora is of what? Plants itself. So soil organic matter which will be there, it can be undergoes decomposition. Okay. Which material can be undergo decomposition? We have already know that, that is biodegradable material undergo what? Decomposition itself, isn't it? So through soil microorganism, through soil micro as well as macro organisms and plant. If organisms are there, that we call it as a fauna, F-A-U-N-A, and plants are there, that we call it as a flora. Okay, botanical names, these are given by the IUPAC, botanical. So soil organic matter which will be there, it can be undergoes what? Decomposition, isn't it? So it will be undergo the decomposition, and through soil micro as well as macro flora and fauna, that is organism as well as the plant. Okay, that is fate of organic material added to the soil. So this can be go and mix in the soil itself. Next, finally what will happen? The final degradation or decomposition, final degradation made by soil microorganisms. Okay. Final degradation means final decomposition can be made by what? Soil microorganisms. They are also play very important role in the SOM itself, isn't it? So why? Because they can be made finally degradable part. Again, final product is humus type material. So what? Final product is humus type material. Humus type material. Okay. Which has carbon and nitrogen ratio around 9:1 to 12:1. Okay. So what final product we will get, which is humus type? Humus type means what? I hope you saw the earthworm or vermicompost, how it can be present humus in the nature. If you hold in your hand like this, no, they can be capture or molding of your shape of hand itself. Such type is available, soil is available, then that's humus is more in that, we can consider it. Then which has a ratio, carbon and nitrogen ratio, carbon is of 9 to 12 and nitrogen is of 1. Okay. This ratio range we are having in that. If it is present, more humus type. And next, lastly, final degradation, all complex carbon products are converted into simple compound. All complex carbon compounds get converted into what? Simple compounds. Okay. Complex material get converted into what? Simple itself, isn't it? Complex get converted into simple. So this is about the fate of organic material. Now in the next class we will going to deal with nitrogen, about nitrogen cycle, in that nitrogen fixation, conversion of nitrogen in soil and mineralization. So what is the today's part we have deal over here? Deficiency of an element, insufficient level. Next, toxicity means what? Next, about nutrients, their chemical formula, in the form in which plant can be absorbed, in that primary nutrients are there, secondary are there, micronutrients are also there. Next we saw about soil organic matter. It consists of living, dead. Again it is chemically active in the nature. It promotes the soil texture. Contains, it can be activate the buffer of soil, promotes the air and good function of SOM we saw, isn't it? in that micronutrient secondary 20 times more water containing, it contains cation anions, carbon, nitrogen, phosphorus, sulfur ratio we saw. Again pesticide, wetticides, it can be affect the breakdown of. Again chelate micromolecules just like of zinc, manganese, copper we saw. And again about how it can be buffer act, that we saw. And next we saw about the weight of organic material, isn't it? These are all about today's part, and in the next class we will going to deal about nitrogen cycle.